I'm going to be working with example 4.4 with section 4.4. This is example number 5, and number 5 and 6 are both a couple examples I did not get a time to do, so I'm going to go ahead and do them today in this video. Okay, so example 5, we have basically three problems to do. We're going to evaluate for each of these following. We're going to evaluate for the cosine of 4 pi over 3. We're going to evaluate for the tangent of negative 210 degrees. And we're going to evaluate for the cosecant of 11 pi over 4. I will be using the unit circle to help identify where the terminal side of those angles exist. And when I say where, I'm talking about which quadrant. Okay, so to help out, I'm going to just kind of draw out this angle. I got 4 pi over 3. So once you become familiar with the unit circle, you'll see that this is 1 pi over 3. This is 2 pi over 3. This is 3 pi over 3. And then 4 pi over 3 would be about right here. Okay, I'm going to go ahead and draw that right triangle then. We've mentioned reference angles. The reference angle is created by the terminal side of your angle and the closest portion of your x-axis. So this is your reference angle for 4 pi over 3. So if you're thinking about this, we're going to 4 pi over 3 this way, and we're going to back up that much. Okay, so I know how much this is, because if this is 4 pi over 3 to here, and this is 3 pi over 3, which is 1 pi, then this has to be pi over 3. So all I really need to do is find the cosine of pi over 3. Well, I say all you need to do is one little minor thing. All right, so cosine of pi over 3, and again, this is why we just did the first quadrant. Of course, you know the first quadrant reflects over here to the second quadrant. Second quadrant reflects down to the third quadrant, and the third quadrant reflects over to the fourth quadrant. But I'm just going to look for pi over 3. Pi over 3 is right here. The cosine is equal to 1/2. But we are in the third quadrant, and in the third quadrant, I know that cosine is negative. Okay, so there's your answer for part A. Okay, part B, I'm looking for the tangent of negative 210 degrees. So let's kind of sketch out where that might be. Well, I know this is negative 90. This is negative 180. I got 30 more degrees to go. So about there would be negative 210 degrees. So let's find that reference angle. The reference angle, again, is created by the terminal side of the angle with the closest portion of the x-axis. So that is your reference angle. Now, as I was drawing this out, remember I said that I know this is 90 degrees, this is 180 degrees, and 30 degrees more would be negative 210. So I know this is a 30-degree angle. So again, back to our unit circle, let's find the 30-degree angle. Here it is right here, and that's our ordered pairs. We're looking for tangent. Tangent is going to be y over x. The tangent of, and we're looking for 30 degrees, is going to be y over x, which is 1/2 over the square root of 3 over 2. So let's work that out. 1/2 divided by the square root of 3 over 2. We multiply by the reciprocal. Cancel those 2's out, I get 1 over root 3. To save us some time, I'll go ahead and rationalize that. Our terminal side is in the second quadrant. In the second quadrant, only sine is positive, sine and its reciprocal cosecant. That means tangent is negative, so I got negative square root of 3 over 3. All right, that's the answer for B. All right, next one would be C, the cosecant of 11 pi over 4. All right, so I know this is 1 over 4. No, let me take that back. I'm sorry. This is 1 over 4, 2 over 4, 3 over 4, 4 over 4, 5 over 4, 6 over 4, 7 over 4, 8 over 4, 9 over 4, 10 over 4, and 11 over 4 right there. So that's our terminal side. So let's identify the reference angle. All right, so I'm gonna back up just a little bit. I did say 1 over 4, 2 over 4, 3 over 4, 4 over 4. So this part right here is equal to 1/4 pi, or pi over 4. That's our reference angle. All right, so I'll do the work down here. I'm looking for the cosecant of pi over 4. Pi over 4 on our unit circle is right here. And our ordered pair is square root of 2 over 2 and square root of 2 over 2. Okay, but cosecant is the reciprocal value of sine. Sine is the square root of 2 over 2, so cosecant is going to be 2 over the square root of 2. And let's rationalize. Cancel out, and I get the square root of 2. Okay, so we are in the second quadrant. In the second quadrant, sine is positive. Sine and its reciprocal function, which happens to be cosecant, so positive value. Okay, so that's example number 5. In example number 5, the most important thing is, where does the terminal side end? And important but not as important is, what is your reference angle? Because once you find your reference angle, you can use the first quadrant of your unit circle to find the values that you need. Okay, the next thing is example number 6. And then in example number 6, it says let theta be an angle in quadrant 2. So theta, and you're going to see this written like this quite often. All right, theta is your angle. It's in quadrant 2, but you might see it written like this. Okay, so let me focus that just a little bit. Okay, so this just tells me that theta is between pi over 2 and pi. Pi over 2 is that 90-degree angle, and pi is a 180-degree angle, and everything in between is quadrant 2. So you might see it written like that. Okay, so I know theta is in quadrant 2. I know the sine of theta is equal to 1/3, and I want to do 2 things. 1, I want to find a cosine of theta, and 2, I want to find the tangent of theta. Okay, so let me just do a little quick sketch. I know the angle ends in quadrant 2. I'm just going to draw an angle anywhere in there. I'm not saying that's a 150-degree angle. I'm not saying that's a 135-degree. I'm not saying anything. I'm just saying that the terminal side ends in that quadrant. Go ahead and draw a right triangle out. And of course, we all know that sine is equal to the opposite over the hypotenuse. So the opposite side has to be equal to 1, and the hypotenuse has to be equal to 3. Okay, and we're only talking about the lengths here. Okay, all right. So what I'm going to need is I'm going to need that third side, and I will need that. So let's use the Pythagorean theorem, and I'll just call that x. Okay, so remember when I find the square root of a number, it could be the positive and negative. In this case, it's going to be negative because we're going left from the origin. So -2 root 2. That helps me out when it comes to knowing what the signs are for our values. Okay, cosine is adjacent over hypotenuse. So -2 root 2 over 3. I don't need to rationalize that. That's my final answer. And tangent is going to be opposite over adjacent. So opposite over adjacent. Let's rationalize. And that's going to be -4. I'm not going to write that negative down in the denominator, so let's just put it right there in the middle. Okay, so the key here again is knowing where the terminal side ends, knowing your ratios for sine, cosine, and tangent, applying those ratios to the appropriate sides, find that third side using the Pythagorean theorem, and then from there you can find cosine, tangent, or whatever else you're looking for. Okay, so that was example 5 and 6 from section 4.4. I hope that helps out. And if you have any questions, please ask.